All right. So we want to solve inequalities today, and I know that since you guys have awesome math talents, you guys can all solve that inequality, right? You're like, if the test was on that, I get an A plus. But the test isn't on that. Yesterday I taught you how to do this, right? So that's a nonlinear. There's a lot of nonlinear inequalities. For example, we could have a square root of x minus 1 divided by x plus 2 minus 3 is greater than 0. Well, you know what that graph looks like, right? You have no idea what that looks like. You have no idea at all. You have no idea what that looks like. Just that expression, so you can focus on that. You have no idea what that looks like. So then how do we find the solution? And you plug it in. No, but I will show you how you find the solution. We go through a table testing method. We start with gathering all terms on one side. And set equal to 0. That's the first step. Get all the terms on one side, set it equal to 0. Second of all, you want to write it as a factored expression. If it's a rational expression, factor the numerator and denominator. But I'll note, just if possible, it might not be possible to factor the numerator or the denominator. Create an interval. Put your zeros on the interval. We make a table. A table has rows and it has columns. The number of columns equals the factors plus 1. The rows equal the factors. Finally, to solve, we test points. Right now, you're just writing stuff down. We have no idea what any of this stuff really means. We're going to show you an example, and we'll connect it all together. You'll be like, okay, I'm seeing this piece together, okay? So we have a little bit of space right here, don't we? We're going to do the same problem. We're just going to set it up this way. I would never expect that if a student got to the test and they saw x squared plus 2x minus 8, that they would solve it like I'm going to do now. I would expect you to do it like we did yesterday. I just want to show you an easier example, okay? So if I follow this testing table method, here's what I do, okay? Gather all the terms on one side. Check. Factor. Check. Make an interval and put your zeros on it. I actually put the zeros on top instead of underneath. I'll show you. Got the interval with the zeros. Now I make the table. The table's going to have how many columns? How many factors are there? So how many columns will I have? 3. And if I just drop my lines down for my zeros, I've got 3 columns. How many rows will I have? 2. And I put my factors on the outside. Sweet. Now we test points. What's the number to the left of negative 4? Negative 5. So negative 5 plus 4, negative, negative. What's the number between negative 4 and 2? We get a positive and a negative. Number to the right of 2? 3, you get positive and a positive. Two negatives, we'll look at my factors. They're always going to be multiplied or divided. So I got two things times each other. Negative times a negative is a positive. Positive times a negative is negative. Positive times a positive is a positive. So therefore, in this situation, I have a solution set. Am I looking for it's less than 0 or greater than 0? So is that negative or positive? Negatives. So I got from negative 4 to positive 2. That's my solution set. Yes. I'm looking for less than 0, so I'm looking for its negative. Okay? All right. Now, Jesse asked a great question. We just did that problem. Yes, we've already done it before. But now we'll see how to do a more challenging one. Okay? Look at this example. I start at the beginning. Set everything equal to 0. Is it? Factor it. Is it? Okay, select the zeros. What are they? Awesome. So I make my table. Got my interval. Got 3 points. Negative 3, positive 2, positive 4. How many columns? How many rows? And that's how I set up my table to organize my work. The table is simply just organize your work. Why am I even setting up the table? Why am I not sketching the graph? Yeah, we don't know what it looks like. We don't know what that graph looks like. We got no shot. Okay? So we better test. Negative 4. Negative, negative, negative. My favorite number? Negative, negative, positive. 3, positive, negative, positive. 5, positive, positive, positive. Notice our expression says we're taking a value times another value and dividing it by a value. So when we're multiplying, dividing, 3 negatives make a negative. 2 negatives make a positive. 1 negative. Does it ever matter how many positives there are? The fact that there's 1, 2, or 3 positives, does that matter at all? What matters is the number of negatives. That's what matters to us. Are we wondering where this expression is negative or where it's positive? We're wondering where it's negative because it says the expression is less than 0. It's negative here, and it's negative here. Would you agree? Therefore, my interval is from negative infinity to negative 3, union with 2 to 4. You're going to set up D on your own. Now, as you look at it, obviously it's set equal to 0. It's factored. Just some people get confused. The negative 3x, what's the 0 there? It's 0. So 0, 5, negative 2, and 10/3. So go ahead, set up your chart. See if you set up the chart on your own. See if you do your testing and try to come up with the same testing results that I do. I'm going to pause this and slowly work behind you. Okay, pause where you're at. What number did you plug in that was to the left of negative 2? If you plugged in negative 3, I start with a positive, and then negative, negative, negative. You may wonder why I chose to write these all right away. I knew a negative times a negative was a positive, so the first two would be positive, next two would be negative. But I think it's more challenging to say plug in -3, then plug in -1, then plug in 1, then plug in 4, and then plug in 6, and then move to the next one. I think it's easier to just grab a number and go straight down. So what's the number between 0 and 2? -2 you plugged in? -1, you should get 2 negatives. What's the number between 0 and 10 thirds? 1, you should get 3 negatives. Between 10 thirds and 5. 4. First time I did it, I plugged in 3. I realized I made a mistake. 3 is not smaller than 10 thirds. 10 thirds is 3.3 repeating. So you should plug in 4. You should get 2 negatives. And then when you plug in 6, you just get the 1 negative. So now is the only time I'm focused on the inequality sign. Am I wondering where the answers are positive or where they're negative? Positive because of that symbol. Now, be very careful here, okay? Very careful. This is something we don't see yet, and this is where people can get confused. We have to see this part through, okay? So I know that I'm looking here and here, right? Now, it's an equal sign. So should I have open circles or closed circles? Closed. Except I only fill in those two. I don't fill in the other two. You tell me. Because if you actually did plug in -2, that would give you 0 in the denominator, right? Can you plug in -2 to this expression and get a result? Not at all. So even though you see the equal sign, you're like, oh, well, that means I should definitely, put brackets on everything. We can't put brackets on the -2 or the 10 thirds because that would give us 0 in the denominator. So therefore, the correct answer is parenthesis -2 to 0 bracket union parenthesis 10 thirds comma 5 bracket. Might be the two middle. Might be the outside. Okay. Is it set equal to 0? Got to make it one fraction. What's the common denominator? The numerator is 4x minus what? Minus 4x, then what? Minus 6. All over 2x plus 3 greater than or equal to 0. 4x is gone. -6 over 2x plus 3 greater than or equal to 0. You want to keep the negative or get rid of the negative? You want to keep it? Awesome. We will keep it because I need to teach you either way. I need to teach you what happens if we keep it. I need to teach you what happens if we don't. I would encourage you to get rid of the negative all the time. Can the top ever be equal to 0? Can the top ever be equal to 0? Can the bottom? Yes. At -3/2. Okay, all right. Okay. Let me rephrase. What number here would you plug in to get 0 in the denominator? -2. So that's, we test -2 still, okay? Yet you can always have a 0 in the numerator, but, so you're absolutely right, Jessica. You may not plug in -3/2, okay, because that would give you a 0 in the denominator. But we need to consider where it is equal to 0. Our final answer, Jessica, could never look like this. It could never look like that. But it sure as heck can look like this, because that's where the denominator would equal 0. Okay? All right? So, here we go. How many columns? 2. How many factors? Is it 1 or is it 2? Okay, now here's the deal. Okay, this is where the negative comes into play. We'll show you. 2x plus 3 is obviously one of those factors, correct? 2x plus 3 is obviously one of those factors. But the -6, does a negative change the solution? Like, do negatives help, you know? Yeah, it does, doesn't it? So if it was a +6, you wouldn't add that extra row. You could, but we have a -6. So watch what happens, and trust me, you'll understand it now. I have a -2 that I could plug in, right? Is there anywhere to plug in that -2 for here? -6 is just always, it's just always negative, isn't it? So I have to account for that negative. I plug in -2 here, and I get negative. All right, let's plug in 0. Is there anywhere to plug the 0 in for the -6? It's just always negative. If you plug in 0 here, you get positive. So 2 negatives make a, and 1 negative. Are we wondering where it's positive or where it's negative? We're wondering where it's positive due to the greater than 0 symbol. Okay? So it's positive back here. Now, should I fill in the circle or should I leave it open? This tells me to fill it in, but what it would give me 0 in the denominator, wouldn't it? So -infinity to -3/2 with a parenthesis, not a bracket. Now, watch what happens here, okay? I'll do it in red. So who said get rid of the negative? If I multiply both sides by a negative, what would happen to the sign? It would switch, okay? All right? Then this would be positive, this would be positive, this would be positive. So this would become negative, this would become, and will we be wondering where it's positive or negative? So we still get the same solution, right? Yeah. You wouldn't have to include the 6 in that scenario. Okay, last one. I know that this is challenging, which is why you will practice all weekend. What's that? Yes, I will pause. All right. This expression right here, as Gigi is writing, when I start at the beginning, is this expression equal to 0? No. So therefore, gather all of your terms on one side. Make a common denominator. What's the common denominator? So good. We distributed the negative 3x. We've got an x and then minus 3x squared and minus 3x. It's less than 0. Combine those, negative 3x squared minus 2x over x plus 1. I would love to take out a negative x. Whoop, sorry. I was listening to what you were saying. 3x plus 2. I want to get rid of the negative. So times, multiply through by a negative, and switch the sign. What are my zeros? How many columns? How many rows? What number to the left of negative 1? What's the number between negative 1 and negative 2/3? Thank you. First person to say it today, or in even many years. So I would refrain from trying to plug in negative 3/4 or negative 5/6. Just go to a decimal. Negative 0.9. That's a nice, easy number to multiply by. Sure, negative 0.8 is fine too. But we'll do negative 0.9. 3 times negative 0.9 is negative 2.7. Plus 2 will be a negative still. But negative 0.9 plus 1 will be a positive. Give me a decimal between negative 2/3 and 0. Sure, negative 0.5, or I like negative 0.1. That'll be the one I like. 3 times negative 0.1 is negative 0.3. Plus 2 is positive. And negative 0.1 plus 1 is positive. And finally, we plug in a positive number like 1. Positive, positive, positive. Are we 1? Oh, let's see. Okay, and now we go through 3 negatives, 2 negatives, 1 negative, 0 negatives. Notice how it seems to always switch sign. That is definitely not always the situation. It does follow that case most of the time, but it's definitely not. I could easily create 3 problems for you right now where that does not happen, okay? All right, so am I trying to answer where it's positive or where it's negative? Because it says I go by what I use to set up my table. Okay, so it's positive. So open or close circles. There's no question about having closed circles, right? Don't have to worry about that at all. Okay, thank you. I was just going to bring that up. Okay. So, Charlie, if I can identify where you're confused right now, what you're saying is we're looking at where it's positive, yet we included negative values, right? Okay. These are the x values that you would plug in. Your output, say your y values, will then all be positive. So you might plug in some negative values for x, but the output the result will be positive. Because you see it's greater than 0 doesn't mean that your x's all have to be greater than 0. They could be anything. But they will all result in a positive output. Does that help? That is a point of confusion that many people have. Was there anybody else who was thinking somewhere along the same lines as that? Nobody. All right. There you go.